Hello everyone. In this video, we are going to see the basics of orthographic multi-view projection and how to draw the projections of a simple solid object placed in the first quadrant. Before that, let's discuss what is meant by projection. Every object has dimension and shape. A line has length and orientation. A solid object has length, width, thickness and shape. In engineering drawing, we want to represent these size, shape and orientation of objects which are three-dimensional to a two-dimensional plane such as a drawing sheet as images. These two-dimensional images of an object are called a projection. For obtaining these images, we need planes, just like films or sensors in camera. These planes on which images of an object are obtained are called planes of projection or picture plane. Usually two views are required to describe an object in engineering drawing and hence two planes are used. These two planes, as you can see, are mutually perpendicular. These two planes are called principal planes. One of these planes, which we see here, is a horizontal plane. We can denote it as HP. The view obtained on HP or horizontal plane is called top view or plan. The other plane is known as vertical plane and we can denote it as VP. The view obtained on VP is called front view or elevation. These two planes intersect along a line and that line is called a reference line or ground line or simply line of intersection. When we draw the projection on drawing sheet, this reference line is denoted as XY line. As you can see, these two planes divide the space into four quadrants: first quadrant, second quadrant, third quadrant, and fourth quadrant. Note that these quadrants are arranged in anti-clockwise order. If an object is above the horizontal plane and in front of the vertical plane, it is in first quadrant. If an object is above the horizontal plane and behind the vertical plane, it is in second quadrant. An object is said to be in third quadrant if it is below the horizontal plane and behind the vertical plane. And if the object is in fourth quadrant, it is below the horizontal plane and in front of the vertical plane. Now let's see how the projection of an object placed in the first quadrant is obtained. Keep in mind that the different orientation of an object relative to the plane will yield different shapes in projection. This time let's consider a cylinder with its axis perpendicular to the horizontal plane. Diameter of the cylinder is 50 mm and length is 100 mm. Top view or plan of the object is obtained by looking from this direction. The point from which we look into the object is called the observer's eye or station point. This station point is assumed to be at infinity. Why it is at infinity? If we look at an object from a close distance, we see the features of the object which are close to our eyes appear larger compared to the features that are far away. This kind of view is called a perspective view, but our discussion in this video is about orthographic view, in which all dimension of an object appears as such irrespective of its position from the observer's eye. That means we will see two different edges of a solid with the same length even if they are separated by say 20 meters from our viewpoint. This happens when the observer's eye is at infinity. You can think of it like we are looking into an object from infinity with an infinitely zoomed in telescope. Okay, back to our top view. When we look from this direction, what we see is a circle. This top view, which is a circle, is obtained on the horizontal plane. The diameter of the circle is equal to the diameter of the cylinder. Now this image is obtained with the help of projectors, also called lines of sight or visual rays or simply rays. These are straight lines drawn from the point of the contour of an object to the planes of projection. Now to obtain the front view, we have to look from this direction. As you can see, the front view is a rectangle with the height equal to the height of the cylinder and the width equal to the diameter of the cylinder. This view is obtained on the vertical plane. We have obtained the top view and front view, but these views are now on two planes which are mutually perpendicular. But we generally use drawing sheet to draw the projection of an object which is a 2D plane. So in order to convert these views to a single plane, we have to rotate the horizontal plane clockwise so that the horizontal plane aligns with the vertical plane to become a single plane. Now this can be drawn on a drawing sheet. One more point to discuss before we start drawing the projection on the drawing sheet. As we have already seen, the projectors or visual rays are parallel to each other and perpendicular to the projection plane, and hence this projection is called orthographic projection. You can also see that the exact shape of the object is represented by two views. This kind of projection, in which the exact shape of the object is represented by two or more views, are called multi-view projections. Multi-view projection is a kind of orthographic projection. There are other kind of orthographic projections such as isometric view. We will discuss about these in future videos. Now let's start drawing the projection on a drawing sheet. First of all, draw the reference line as a thin line using H or 2H pencil. Mark it with the small letters X and Y. Now draw the top view as a circle with a dimension 50 mm as a thick line using HB pencil. For this particular case, the distance of the object from the vertical plane is not mentioned. So you can draw the top view at any distance from the XY line. From the top view, draw projectors to the reference line. Projectors are thin lines and they are perpendicular to the reference line. Again, the distance of the object from the horizontal plane is not given. Hence, you can draw the front view at any distance from the reference line. Complete the front view with a height equal to the height of the cylinder. The front view should be drawn as thick lines. Draw a projector line from the center point of the top view to the front view to mark the axis. The axis is drawn as a chain line. Mark the height of the front view. Instead of writing the unit in all places, you can write all dimensions are in mm in the bottom right corner. You can also specify the scale. If your projection measures the exact dimension you have written down, then the scale is 1:1. Okay, that's it. We have completed drawing an orthographic multi-view projection of a solid in simple position. This is only an outline of engineering drawing. We have not discussed many of the details such as a dimensioning format, title block, etc., which I plan to do in future videos. In the next video, we will see how to draw the side view also. Please comment your suggestions and thank you for watching.